Today's first session on wireless physiological monitoring with wearable medical instruments, possibilities and challenges will be handled by Dr. Tushar Kanti Bera, Assistant Professor, Department of Electrical Engineering, NIT Durgapur. Dr. Tushar Kanti Bera received his PhD degree in Biomedical Engineering from Indian Institute of Sciences, Bangalore in 2012. He did his MTech in Electrical Engineering from University of Calcutta, West Bengal in 2003 and BE in Electrical Engineering from Jalpaiguri Government Engineering College, West Bengal in 2000. He also worked on EIT and EAS and other impedance-based techniques for non-invasive health monitoring and biomaterial characterization for more than 15 years and contributed to the same through the following research activities: EAS and EIT, biomedical and medical imaging during his PhD at IISc, EAS and EIT for conducting fabrics-based wearable material characterization during his postdoc research in South Korea, EAS and EIT based carbon fiber reinforced polymer characterization during his postdoc research at KAUST Saudi Arabia, impedance-based characterization of graphene-based nanomaterial sensing and actuating during his postdoc research at KAUST Saudi Arabia, studying the brain tissue using electrical impedance analysis and acousto-electric imaging techniques during his postdoc research in the USA. He is presently working as Assistant Professor, Department of Electrical Engineering, and Associated Faculty Member, Center for Biomedical Engineering and Assistive Technology in National Institute of Technology, Durgapur. His research interest includes biomedical engineering, instrumentation and measurements, sensors and actuators, medical imaging, computer tomography, electrical impedance-based health monitoring, ultrasound-based medical imaging, neuroscience and neuroengineering, MEMS and nanotechnology, and non-destructive testing. He has over 32 publications in journals and 33 publications in national and international conferences. He has been resource person in many FTPs, seminars, webinars, and conferences. He is a member in professional bodies such as IEEE, ISCBI, IAENG, ISOI, AMPA, and ISTE. Now I hand over the session to Dr. Tushar Kanti Bera. Over to you, sir.
Thank you very much for nice introduction. Yeah, I'm very much pleased today for becoming a part of this FTP. So I will share my screen. Is it visible now?
Yes, sir. Yes, it's visible.
Okay, I will switch off the camera so that there will be more bandwidth. Okay.
Okay, sir.
Okay, today I am going to talk about wireless physiological monitoring with wearable medical instrumentation, possibilities and challenges. So thank you very much for giving me an opportunity here. So at the starting of the discussion, I would like to tell about little bit about the background of biomedical engineering, and after that I will come to the wearable devices which are used in the biomedical engineering. So in biomedical engineering, that is the multidisciplinary field which is developed with biology, medicine and engineering. We know that science came first when we understood there should be some certain laws and theories to explain the phenomena we found in the nature, either inside the body or outside in the atmosphere. So, and then utilizing those knowledges which are found in science studies, we tried to implement those theories in the practical development, practical device development. So the engineering came, and whenever the medical science came, that is the field of studying the human physiology and anatomy to keep our society healthy. We found some instruments are helpful for detecting some parameters or physical signals to help the doctors for detecting disease or treating the diseases. So then engineering came into the medical science, and in this way the researchers or scientists from science, biological science, and doctors from medical science, and engineers from the engineering field, they came together and they worked together, and in this way the biomedical engineering is evolved. Now our human body is very complex. There are several organs, several number of cells, tissues, and there are several systems. There is muscle system, skeletal system, circulatory system, nervous system, and lymphatic system. There are several systems which has the responsibility of performing a particular work periodically and till the life ends. They has to work as healthy as possible. But due to some unfortunate events or unfortunate incidents, either our human body sometimes got injured, or sometimes it receives, unfortunately or unwillingly, it receives some microbes or bacteria from the atmosphere which are not good for our health. So we got sick, and since the ancient age there were several doctors or physicians who tried to study the human body better than the common people, and hello. Hello, am I audible?
Yes, sir, you can proceed. Sorry.
Okay. Some sound was coming actually. I thought that
Yes, I muted.
Okay. Thank you. So whenever the doctors were trying to detect some abnormality in the human body, initially they started with their visual observation, touch, sensing capability, hearing, power, and all, because no instrument was there. So the diagnosis was not very accurate, not very effective. Sometimes the doctors could not understand what is happening inside the body. So after several years, the science came and medical science is developed, engineering came, and so the scientific theories and engineering technologies are used to understand the medicine field and to develop several instruments for detecting any disease if it is there inside the body. So researchers, scientists, and engineers, they contributed to develop the technology, and then that technology is used in the industry. So device is developed, and then doctors, medical practitioners, and clinicians are using those instruments. Several instruments are there, medical instruments. All those instruments are used for giving the better health quality in hospitals and in our society. So starting from a thermometer to a complex instrument like say vital sign monitor or heart-lung machine, we have several instruments. So I am discussing mainly on the electronic instruments here today, but here I have listed several instruments which are used by the doctors and clinicians. So modern diagnosis can be classified by two types: the signal measurement and imaging. So those two types of experimentation are done for detecting any disease. Signal measurement may be invasive, minimally invasive, and non-invasive. Invasive means we are inserting some object or instrument or the part of the instrument inside the body, like this blood pressure monitor, any kind of physiological signal monitored by this catheter, which is inserted into the hand or inserted into the vein. So this is called invasive. Minimally invasive means it is put inside the body cavity. So we are not cutting anything, blood will not come out. So we will put in the cavity suitably for measuring the better signal, like thermometer we put either inside the ear or inside the mouth. Non-invasive, so we are not putting inside, only the instruments are put on the surface of the body. And also non-contact means we are not putting anything on the body, we are just giving some signal wirelessly and we are taking the response. That is called wireless technique or non-contact. So signal may be either temperature, blood pressure, oxygen saturation, blood count, etc. And imaging, till this point we are getting only the values, like in a graph, say 1D graph or 2D graph. So that this type of signals are found in a graph, but imaging means we will get the impression of the body tissue exactly similar to the anatomical aspect of the body, like say X-ray imaging, we are getting the images of the bones here. Sometimes we will get the images of bone and muscle both in different imaging. And imaging techniques also may be invasive, non-invasive and minimally invasive. And it can be wireless too. So there are several instruments starting from electrocardiographs, echocardiographs, electroencephalographs, hearing aid, CT scanner. We might have come across few of the instruments in our daily life, or we might have seen in the hospitals or clinics. So with the help of the technology, we found blood pressure monitor, ECG, EEG, planar radiography, which is used for detecting the breakage of bone, and then tomographical device, X-ray tomography, magnetic tomography, MRI, magnetic resonance imaging, positron emission tomography, ultrasound like echocardiography, or fluoroscopy or endoscopy. These are the few, there are many. So starting from the basic instrument, vital sign monitors are used whenever any person got sick, and if they are going to the hospital, some instruments are connected directly in the emergency room to understand some vital signs. First of all, they will measure the ECG, heart rate and blood pressures, oxygen saturations, many things can be so. Respiratory rate, the breathing rate, heart rate, so several things will be there. So what is, I will discuss about the wearable instrument, but before going to the wearable medical devices, I will just explain the basic theory of each instrument and then I will go to the wearable devices. So ECG monitoring can be done. ECG, what is ECG? Electrocardiography. Our heart is developing the electrical signals to make our heart muscles beating with a particular rhythm periodically. So that heart signal or heart electrical signal can be measured to detect the cardiac health, that is the heart health. So this is the electrical path through which the electricity is spread over the heart. It is not spread all over the heart. If it is spread all over the heart, then heart will not work properly. So these green color lines are showing the electrical circuits, or it works like the electrical conductor, whatever we used in our laboratory. So similar things, but these are not the matter. This is the biological materials developed by nature. So it is periodic and related to the heart health, because if the electricity generation is proper, definitely heart will work as per our requirement of the body function. Body function will be okay. But whenever the generation or the conduction of electricity, anything is disturbed, then automatically heartbeat will be disturbed, breathing may be in a problem, and we may have some health issues. So how the electricity is generated? So whenever some electricity is there, it can be felt from the touching of that electricity. There may be some voltage, like our household plug point are there. Many of us who are listening or who are in the discussion part might have experience with electrical shock, unfortunately. So that is whenever we have touched some live wire or touched some conducting wire, we found the electrical shock. How got the electrical shock? Because there will be some voltage available. Until unless we touch, it cannot come out and it cannot touch us, because there is air is insulated in nature. So that's why we all are safe until unless we touch it. So whenever we put something conducting in nature, we can get the electricity, because electricity can flow through that conducting material. In our body is entirely conducting because it is made up of water, blood and muscles, which are very good conductor of electricity. So whatever is generated inside the heart, that can come out easily to the surface of the body. So as at the surface of the body this voltage or the heart voltage is available, so we can put some sensors called electrodes. Here it is called ECG electrodes. And we can put some electronic circuits which is there inside the machine, and we can amplify the voltage if the voltage is not very good to measure, because if the voltage is very less, then there will be less signal to noise ratio. Noise may be more, signal may be less. So we can amplify it, we can filter it. So amplifier and filters are there. Those are electronic circuits, and we can get some waveform which is called ECG or electrocardiogram, and that can be printed by the machine. This is called ECG machine printer. So it was invented by William Einthoven long back, and he developed a very big machine at the initial stage, and after that this type of machines are there, which is called portable electrocardiography machine. So electrocardiography machine can be found as wearable also. That type of instruments can be utilized. So this is, say, measuring the ECG, and that is measuring the ECG as well as the blood pressure. So with a combination of several electronic circuit, we can measure several body parameters, several physiological parameters, and we can put that with our clothes. We can put those instruments with our belt so that we can carry it, and we can wear if it is put in the jacket or any other clothes. So what is done? Electrodes are put inside the body, either on the hands or legs or any place of the body where the voltage is available. And we can put some amplifier. IA stands for instruments amplifier, then low pass filter, high pass filter, notch filter, and several other display units will be there, so that we can see the signal, and printer may be also there like this, so signal may be there. So after reading those waveforms by the doctors, we can get the idea about the heart health. So this is one portable ECG monitor. This is much more portable, and some ECG monitors are also used to measure the cardiac health during the work. Suppose some diseases are there which is only appearing during our work, whenever the body is in exhaust condition. So that's why doctors are always suggest that if you run on the treadmill and then your heart will be under pressure or under stress, then heart will show its say inability or its problem. Otherwise, whenever people are walking, sleeping, talking to someone else, teaching or something other small work, not physical exhaust is there, then the heart will work normally, but heart may have some problem at the time also sometimes. So this type of techniques are called stress test, treadmill test. We can put the ECG circuits like this. So in that type of experimentation, or whenever we are running in a ground, if some abnormality came, we found that some heart problem is there, but whenever we are going to the clinic, that heart problem disappeared. So that was awkward situation. We understood that some problem is there, but we are unable to show it to the doctor. So from that type of situations, the wearable concept came. So if the ECG machine is put in a very portable form, and it can be weared on the chest like a band-aid or something else, or even as a, say, CD drive or small hard drive kind of thing on our waist, we can store the data throughout some work, and we can save it for the doctor's discussion. So that type of things may come. So Holter monitoring came with that concept. So some cardiac arrhythmia. Arrhythmia means it came from the and rhythmia means the rhythm is disturbed. So arrhythmia means the heart is not beating in a particular rhythm. There are several kind of heart arrhythmias, but that may appear say irregularly. So it is very difficult to detect if it is not coming very frequently. So in that type of situation, if some cardiac arrhythmia is there and patient is feeling some discomfort, some may be very dangerous and some may not be very dangerous, and some are very normal. Even cardiac arrhythmia is found more than 80% people in the world, but we don't understand that is cardiac arrhythmia, because we sometimes feel that our heart starts beating 2-3 times together very fast and then it start beating normally. So that is called cardiac arrhythmia. That may happen due to the excessive work, due to the some stress, physical stress or mental stress, and it may disappear whenever we take much rest, take much sleep. It is fine for the human body, but sometimes it persists, and that is the time when we should consult with the doctors. And you can put the ECG machine electronics here, and you can put the electrodes here, and this is available from the clinics only. You can purchase it personally, and after that there will be one drive, storage drive, either it may be USB flash drive. Earlier it was like some other devices. Now it is as USB drive came, so the volume of the Holter monitor become much smaller, and we can took it to the hospital, and they will take that to the machine, and they will see 24 hours ECG. So how, at what time, during the eating, during the watching TV, or at what time, because the doctor will give a diary and you have to write the time, at what time you wore this instrument and at what time you remove. Accordingly they will get a time scale and they will understand during what work, because your diary will tell that what time you do dinner, at what time you do breakfast, during at what time you did some exercise, kind of. So everything will be. Nowadays the instrument become very portable. There will be few buttons and it will look like a mobile. So these are the ECG monitor. If you touch in particular places, then you will see your cardiac rhythm, electric signal, electrocardiography. And sometimes these instruments are much smaller and display is used from the our smartphone. So there will be some Bluetooth connection or any other wireless connections, and we can see our cardiac rhythms here. Now, similar to the cardiac signal, blood pressure also is possible to monitor. Blood is there for the conduction of oxygen, removal of carbon dioxide, and supply of energy element. So whenever we need some energy, we need to have food. The food will be digested in our stomach, and the energy element will be absorbed by the blood, and it will be put to the cell, and inside the cell it will be burnt just like a fuel, and energy will be developed in the mitochondria, what we studied in our 10+2 science. So blood is a conduction medium, and that blood is pumped by the heart, because there will be pump to send the liquid, whatever we do for our garden, to give the water to each plant so that they can also get food from the soil. So for sending water to a particular point, sending liquid to a particular point, we need to pump it. So that's why we need also pump, and our nature has given a pump to us, and that is called the human pump or human heart pump, that is called heart. And then the blood is pumped by the heart, and it is flowing to the tissues, to the cells by the vein, and it is by the artery, and it is coming back through the vein. So paths are different because there are some pure blood and say impure blood, that is carbon dioxide mixed blood or oxygen mixed blood, oxygen enriched or carbon dioxide enriched. Carbon dioxide enriched blood is not good, because carbon dioxide is not good for our health. So we have to separate the blood, that's why the flow path is different. Now whenever heart is pumping, there will be definitely giving, pumping means it is giving a pressure so that it can flow from one point to other point. So that's why blood pressure will be there throughout the body, and that can be measured as a vital sign of our human body. So bloods are flowing through the arterial veins. So definitely whenever the water is flowing through a pipe, similar phenomena is happening in our body, and water gives some pressure to the pipe wall. Definitely blood also will exert the pressure to the arterial vein wall. So we can get the pressure from the outside of the body, and we can put some instrument to measure the pressure. So measuring means there will be some water pressure measuring gauge, and similar type of gauge can be utilized. Whatever what type of gauge is used for the measuring our 4-wheeler vehicle tires pressure or 2-wheeler vehicle tire pressure. So that is fluid pressure measurement gauge. Similar gauge can be utilized because we are giving some external pressure utilizing the inflatable cuff. So that is inflated by the air. This is the pump which is giving some air, and then we will raise that up to a particular pressure, and then we will release, and we will listen the sound here. That is called coroscope sound by stethoscope. It is put in the ear, and then we will measure the pressure. Means at what value of this pressure this coroscope sound is coming, like that we will measure. So clinician and doctors are very expert for measuring the blood pressures, and depending on the blood pressure there will be several physiological conditions, maybe abnormal, maybe normal. Normal plus blood pressure is 120/80 for a standard human being. So this is a sphygmomanometer, which is mercury based blood pressure monitor, and which needs a stethoscope, which is a device through which we can hear a sound of the body movement, body organ movement. Either it is the blood flow movement sound or blood movement sound, or it is heart movement sound. So these are the portable. So these are the portable devices which can be put on our body and we can move it. So this is little bit bigger, so we cannot move very freely with this type of things. But this wrist-based blood pressure monitor or heart rate monitor, we can wear it and we can move it. So that type of instrument is very much suitable if for the sportsmen who are using say this type of instrument and running during the time, or after or before running also he or she can measure the blood pressures. Then we will come to the echocardiography. Echo comes from the sound, so and cardiography means measurement of the heart parameters. So definitely it is related to the heart measurement and utilizing the sound wave, but this is a special sound called ultrasound. Means we cannot hear that type of sound through our bare eyes, and that sound can be utilized because sound wave can travel through a medium, and if we put that sound ultrasound to a body tissue, its sound will be reflected, it will comes back. So it will come back, and that reflected sound can be also measured. So utilizing the computer program, we can get the movement picture of the heart and also the movement, the moving picture of the heart. So this is called echocardiography, by which we can measure the wall thickness, we can study the heart pumping, and we can measure several other heart parameters, and we can diagnose whether the blood, the heart valves are working or not. So that is a big instrument. Generally it is installed in the laboratory. So in present times few instrument came that is looks like the briefcase or looks like a laptop. There will be one probe only, that is a transducer, piezoelectric transducer, ultrasound transducer, and there will be one laptop, that's all. So we can take that probe to the human body and we can get the picture in the laptop. And also sometimes this is minimally invasive. Whatever is shown here, it is non-invasive, where nothing put inside, but sometimes it may be put inside the throat or inside the cavity, food cavity, so that we can put the ultrasound very near to the heart and we can get the clear image. So those are the called TTE. So electroencephalography. So this is the electroencephalography, means it is the measurement of brain signal. What is the signal in the brain? Our brain is the one of the major part, or it is the central processing unit of the human body. So without brain, the human being cannot survive. So it is a controller. So there are several cells called neurons, and those brain cells are communicating with each other and sending some signals, and that signal is transferred from one cell to other part as electrical signal, and it generates the electrical signal. That electrical signal is much lesser than the electrocardiography signal, but still it is measurable with a suitable amplifier. So if there are several electrodes put on the head, and if we connect the instrument with that electrodes, we can get the brain signals, and that brain signal reveals several information about the brain physiology and brain disease, so that we can detect some disease and we can give the information to the doctors who are studying some brain diseases. So there will be one computer, there will be one cap, or there will be some electrode array which will be put on the head with the help of some conducting material kind of gel, and then it will be connected to the computer, and we will get, there will be several standard, say 1020 system or any other system for putting the electrodes on the brain, and then the brain electrodes will be acquiring the voltage signal, and that tiny signal will be sent to the instrument, and instrument will make it large so that we can get the data or visualize in the computer. So this is another kind of cap where we can put several electrodes, and with some, using some minimal number of electrodes, you can see that there are some instruments inside the cap. We can get some EEG in a portable or wearable form. Then I will come to the pacemaker. It is not wearable, but it is say it is inserted in the human body, whose heart signal generation system is damaged or is not working properly. So doctor suggests some electronic circuit. This circuit is kind of signal generator. It generates electrical signal, whatever is required to stimulate the heart muscle. So it is utilized to help the heart to beat in a particular rhythm. And it was the first say pacemaker, which was very big, but it was used to stimulate some heart. It was not possible to put inside the body, but it should be attached to the body so that the living body can live or continue his or her life. Other machine, heart lung machine, which is used for some surgery. Whenever one person is under the cardiac surgery or any lung surgery, which at that time, if those doctors are feeling that it is not possible to put in the proper working condition for the physics, then they put this machine parallel to this system, which will perform just like a heart and lung. It will send some oxygen and removes the carbon dioxide from the blood, and also it will be utilized for pumping the blood. So heart will be utilized, blood will be bypassed from the normal heart or natural heart. It will be passing through the machine, and it is called heart lung machine, which it will perform the work of heart and lung during the surgery. So that's why it is called heart lung machine. It is not definitely is possible to put inside the body or attached to the body. It will be used for some surgery. It will be helpful for conducting some surgeries. Very complex machine. Artificial heart can be sometimes developed. So with the concept of the heart lung machine, so some work is going on. Artificial heart means there will be some pump, and there will be some cavities like ventricle and heart, say atrial, and then those type of cavities will be filled by blood but separated by walls as per the design of the heart, and there will be some pump which will pump the blood out of the heart, and also the heart will receive the blood coming out from the body tissue. Defibrillator, this is also used for some surgery. If heart stops beating, then we put some electrical signal, and that electrical signal will stimulate the heart to beat. It is good to know that whenever a high voltage is applied to the heart, heart will cease to beat, and again if the high voltage is put again, heart may start to beat. So with that concept, the defibrillator is developed. Okay. So there may be the voltage level of 200 to 1000 volt, and it will be put in such a way that the flux lines will pass through the heart. Okay, this is the portable. Now I will come to the wearable devices. So what is wearable? Wearable things are the materials that we can wear. So it may be from the ancient age, it may be the skin of any animal, it may be the leaves, or it may be modern clothes. So we are wearing something, means it is wearable. So clothes, ornaments, and except the clothes, ornaments may be the wearable things, shoes may be the wearable things, sunglasses, etc. So the wearable instruments. So definitely we will come to the electronic instrument today in our today's discussion. So there will be used in engineering lab, the function generator, oscilloscope, multimeter. In household, mobile phones, radios, television, all are instruments. Hospital and clinics, ECG machine, EEG machine, vital sign monitors. So there are several instruments, whatever we come across in the society, and we will use that for our particular purposes. Now, if the instruments are used as a wearable device, then it is called wearable electronic instruments. And if those electronic instruments are used for biomedical or medical purpose, then we will call those instruments as wearable medical instruments. And if the instruments are wearable, that may be wireless or may not be wireless. If the display unit or the processing unit is on the body only, then there will be no wireless transmission required. So take the signal from the body and it will be processed and displayed in the monitor itself, if the monitors are there. But if we want to monitor, or if you want to measure, or if you want to study the signal from other place, suppose in clinic, from a patient who is running in the ground outside the hospital, at that time the wireless communication is required. And wireless communication is nothing to discuss here, because we all are having the basics of wireless communication, and also the audience and the experts who are present, except myself, they are very, very experienced, because they are from the telecommunication or communication engineering department. So there will be two parts, that is the transmitter part and receiver parts, and the data will be transferred through the air with the help of wireless communication technology. So there will be several modulation technique and demodulation technique. Encoder will be used, decoder will be used, like that. So a basic example, say any ZigBee or any other chip can be utilized for small portable devices. For that we need to select our components, what frequency it will be utilized and what type of signal is required to be transmitted. So as for example, there may be some encoder or decoder ICs like HT640 or HT640L or whatever. This is what, just for an example, what I used during my PhD. So there will be parallel data and parallel to serial conversion, then there will be transmission through the transmitter antenna, and then the serial data will be again received by the receiver, and it will be decoded by the decoder, and it will be again become the parallel data, so that we can get back our parallel data. So this will be the entire schematic I just made as an animation to understand. If anybody from other background they are there, so it will be helpful for them. Otherwise it is very, very well understood. So wearable electronic instrument, and that wearable instruments may not be always for any medical purpose always, but it may be for some, say, for detective, for police, and for other athletes. There may be wearable. Suppose if a person is doing the exercise, he or she can put mobile on the arm, so this is also wearable device, but it not be utilized for medical purpose. But whenever we are taking some other signals and storing in the mobile during our normal exercise, then it will become the part of the wearable medical devices. So soldiers are also wearing several wearable devices, but that may not be always used for the medical purpose. But if so, the soldier willing to get the respiratory signal, cardiac signal, or blood pressure during the climbing in the hills or walking or doing some work, that jacket must have the medical signal acquisition system in the jacket, so it will be medical wearable devices. So wearable technology in healthcare, wearable technology is useful or helpful in a physiological multi-condition healthcare. Many wearable devices have been developed. It may be wristband. It is a company, Fitbit, and with Fit, this is glucose meters may be there. The small portable devices, it may be also utilized for the wearable device, because there are several technology which is utilizing the sweat for sensing some receivers from there, some chemicals which are available in the sweat, and from that we are calculating the blood glucose. So these are all research studies, and that type of devices can be developed. So it may look like a watch, and we can have the sensor stripped at the below of the watch so that it can touch our wrist and we can read the. And there will be wireless communication, US communication or Bluetooth communication, and we can get the data stored in either in the cloud or any other suitable system, and then we can send it to the doctors or in the clinical rooms so that they can be visible to the doctors. So wearable biomedical instruments start from the temperature monitor, a very common and basic instrument, which is the temperature monitor. Works like a wristwatch, and there will be some temperature calibration and temperature measurement and display will be there. It is very helpful for any kid, because measuring the temperature for kid is sometimes difficult. Kids may cry, or kids may be felt irritated. So if it is put on the either hand or leg, then it will continuously measure, and you can just watch the temperature and we can get the data. So from this very basic principle will be there. There will be one strip where some resistive element will be there as a band-aid, and resistive element will take some temperature, and it will become more resistive or less resistive depending on the material. So generally with the temperature, resistance will be more, and this material will give some calibration. It will have some calibration technique, and it will show the display. So there will be one sensor element, and temperature to voltage controller technology will be there, and that voltage will be measured by the some measuring instrument, small amplifier and filter, and then it will be displayed in a LED display or any suitable display. So this is very simple circuit. But here in the smart jacket, there will be several electrodes. This type of sensor also can be implemented here, and blood pressure monitor. So many things can be installed. So multi-sensor smart jacket may be there, and these are the some other wearable devices, smart shoes, Bluetooth key tracker. May not be always for biomedical, but these are all wearable devices and smart devices which will measure some signal and either display in the component, or it will display in the other component in the other room or other places wirelessly. So other wearable digital thermometer can be found as not as a wristwatch. It is more simpler. It is like a band-aid. So this is company brand name. So they can show the there will be a button. There is a one button. We can press it, and it will start working and start monitoring the temperature throughout the time. And it will be monitored and coupled with the mobile phone through the Bluetooth, and we can get the calibration, or we can get the display of the signal, the temperature signal. So this is the material, whatever is disclosed, but it is not fully disclosed, patented material. So they have developed some sensors, thin film based sensors, and they measure the temperature with the change in the electrical parameter. And then wearable blood pressure monitor. Wearable blood pressure monitor also looks like a wristwatch. So we know that our hand cross section will show our two bones, that is radius and ulna bone, and then there will be one artery also, and there will be nerves also. But we have to put the sensor at the artery so that we can get the pulse or the pressure on that sensor. This is the sensing material, and this is the display material. So it will look like a watch. We can put a watch, a wristwatch kind of, and you can get the display of the blood pressure. So from this signal, it will be there. Pressure actuator will be there, pressure transducer will be there, and there will be some other algorithm to detect the signals and display it. Processing layer and the transducer layer. So there will be two layers. And wearable blood pressure will be very helpful for helping the pregnant woman and other patient who needs to measure the 24 hours blood pressure. So 24-hour blood pressure measurement is not very suitable for the cuff based measurement. Cuff based measurement is inflatable cuff is to be inflated, and we need to monitor the blood pressure by clinicians or by the person or patient itself, but it is not feasible. But if it is a cuffless blood pressure monitor like a wristwatch, and it is monitored and it is coupled with the mobile phone display, then automatically we can get our data, and again it will send to the storage device or server or cloud, so that we can it can be available to the doctors also whenever he will be willing to see. So this is also another kind of technology, Internet of Health things. This is simply it is Internet of Things, but it is related to the things are related to the health. That's why it is called Internet of Health Things, IOHT. It will be IOHT. And sometimes they are calling that Internet of Medical Things, so IOMT. Those words are coming because Internet of Things is very emerging field nowadays. So this is the same thing. Any wearable device will be there in the person, and that wearable device will get some data. It will send through wireless. It will be stored in the cloud, or it can be sending that to the any other database, other say analyzer. Analyzer may be doctor or any clinicians or any nurse. So there will be connection of the things. So that's why it is called Internet of Things, through the internet. And also, as it is the medical things, so it is called medical things, Internet of Medical Things or Internet of Health Things. So there are several kind of instruments or wearable instrument can be there for this type of Internet of Health Things, like oxygen saturation, and then the ECG or position sensing, even position sensing also. Electromyography is the measurement of voltage generated by the muscle. This is very, very useful for the athletes or any sportsman whose muscles are working very hard, and sometimes they may get the exhaust and they may be tired, or they may be willing to study their working state of their muscle. Sorry. So smartphone can be very useful component or key component, one of the key component in this type of technology. So there will be several other components coupled with the smartphone through Bluetooth, and this is always useful for our better or ambient assisted living. Means we always get some assistance from the clinical system or medical system, either measuring some physiological parameter, either getting some medicine, either getting some help to survive better or healthy, either in the normal healthy condition as well as during the ill condition. Okay, so this is again IoT mode. Blood pressure, I will just keep those things I have already explained. This is the schematic of one wearable ECG system. The ECG acquisition device will be there near the heart, and this may be there either Holter monitor as a device, or it may be the mobile phone, because our smartphone has several potential nowadays, and there will be several circuit units. So, and then it will be doing the physical activity recording or real-time display or report to the doctor. And this is the example of one kind of wearable ECG monitor, which is developed for getting the ECG in our mobile phone. So instrument will have Bluetooth connection, and it will send to the device. But till now it is with the Apple devices, but they are very soon they will send to the Android platform also. This is a smart shot with ECG electrodes, and it will give the ECG signal acquired by this electrode. So this is nothing but the electrodes, just like performing as the ECG electrodes made up of AgCl, but these are the other conducting fabric electrodes. Conducting fabrics are the fabrics or clothes which are developed with conducting yarn. So, and those are waved as just like the clothes are made, and those are electrically conducting. That's why it is called conducting clothes or conducting fabric, and this is used for measuring the body signals also, because it is very flexible and it can be connected or it can be coupled with the other cotton materials or any other cloth materials. It is very, very flexible. So this is the coupling of mobile and discussion with the doctors, and sometimes the smart chart will be having some other monitoring sensors also, as all the parameters are used. Most of the parameters can be found: blood pressure, temperature, cardiac, and EEG also. But in the heart, here we cannot get the EEG because there is no sensor for the head. If any EEG is to be coupled with that, then definitely the head will have some other sensors, and their connection will be there with the smart chart. So these are the applications for disease monitoring, medical monitoring, biofeedback, clinical trials. Anything can be made with the smart SAT. Smart textile similar to the smart SAT, but even the textile is used for getting some information. The textile can be utilized as a sensor, so it can be also useful for sensing the strain created by the pressure, so it can be found as a pressure sensor. So we also studied the smart textile as a pressure sensor during our postdoc, and we found that material is useful for monitoring the elderly person living away from the family person. If some person is living away from the family, then sometimes that person may get ill, and then they may need the medical help. Now the camera-based monitoring is always there, but whenever the camera is watching a person, the person will be in very uncomfortable mind, and definitely it will not be good, and they will not agree to continue their life in front of the camera because their privacy will be in danger. So nobody will willing to use that camera-based system. Though the cameras are not giving the real image, they are giving some blurred image or any other, either thermal camera may be there will be impression, but still if camera is there, the person will be uncomfortable. So in that situation, we propose the fabric-based, smart fabric-based bed cover, where the person will be lying and there will be pressure, and that pressure will be converted to the image. And if that pressure, that clothes is put on the carpet, and also if we found that for continuous time somebody is lying on the ground, automatic signal will go to the clinics and the ambulance or medical help will be reached to the person. Because if the bed is available, so it is very awkward. So if the person is lying on the ground, so it may be there may be a pressure sensor and vibration sensor for detecting any fall or any kind of accident. That is also there, utilizing the smart textile. Okay, so these are the few devices where we can get the systolic pressure, diastolic pressure, pulse rate. It is made by Omron. Omron is a very famous company nowadays in biomedical wearable devices. So these are the devices which are not always giving the biomedical parameters, but giving some other parameters also are measured, because several times we do some exercise, we have some target that there are many steppings we have to do, so that much of calorie will be burned. So that type of things are also there. There will be vibration sensor, and we can measure how many steps we have completed throughout the day, and we can monitor our health. So EEG, as I told, that EEG can be found as the portable device. So some with some less electrodes like this, we can put just like the hairband, and we can put on our head, we can get the data of EEG. So there will be several models. There may be 3 or 4 electrodes. One will be connected to the ear, which is used as the ground electrode, with respect to which the voltage will be measured, and other electrodes will be measuring from the forehead, and we will get some signals generated by the brain, just like this. And nowadays some other instruments which are coming, they are in the research level. So with the utilizing the sweat or skin, we can get so many parameters regarding that. We can get the pressure from this, so respiratory rate can be measured, ECG can be measured with the help of some other electrodes put on the chest, and some flexible electronics or MEMS device technology can be utilized for developing the sensors which can analyze the sweat, and it can get some signal like say blood glucose or blood oxygenation through this chip. But now how to get that wearable imaging devices? Hello? Hello?
Yes, sir, it's audible. You can continue.
Yes. Yeah, madam, till what time I can talk? Means, what is the time?
Till 11, sir, till 11, I have time.
Okay, fine. Okay, so till now whatever we have discussed, that is the discussion about the physiological monitoring with signal measurements. Means we are getting either any graph or either getting the values of some parameters. but we didn't get the cross-sectional image of the body. So cross-sectional image of the body is found by some imaging device, and it may be X-ray planar radiography, which is done for our the detection of any breakage there, if there is any breakage in our bone, and that type of imaging techniques is utilized for the hospitals. In hospitals, clinics, and several places are there. Some diagnostic centers are also using that, and we generally call that X-ray. But that X-ray is not the proper term. X-ray is the signal which is used to get the image, and the technology is called X-ray planar radiography. And some tomography is there. So tomography means there will be the imaging technique which will get the cross-section of the body. So it will be non-invasive. Definitely, it will not cut or put any harm to the body. There will be some instrument called CT scanner. So CT scan is very well understood or well known word. Several times we heard that in the hospital, CT. So that is came from the computed tomography. Tomography is tomo means the slice, and graphy means the imaging. So tomography is the imaging of a slice or imaging of a cross section. And as it is done by the X-ray, so it is called completely, it is known as X-ray computed tomography or X-ray CT. But in hospital we generally call it CT scan or CT. So whenever images will be there in the doctor's hand, doctor will study by their experience, by their visual capability. And nowadays some data analysis, image processing, signal processing techniques came in our engineering field, and we can put the images, we can load the images, and we can analyze those things in a computer also. Some computer based diagnosis is there, doctor based diagnosis is also still there. So but image analysis is the second part. First part is the imaging. So whenever imaging is required, the patient is lying on the bed, and if it is CT imaging, there will be one opening that is called gantry, and the tray or the lying bed will be there, moving bed. Patient will lie on that, and patient will be taken inside the hole, and there one X-ray rotating X-ray machine or X-ray source will be there, X-ray beam will be there, which will rotate 360 degree after switching on the machine, and there will be data collection, and that data will be sent to the computer. Computer will be connected to this machine, and computer will give the cross-sectional area or cross-sectional image of the body. But which cross-section, where, at which plane the X-ray will move. So X-ray imaging X-ray was invented by Professor Roentgen, and he invented accidentally, and he didn't know what he had invented, but he knew that he invented something. But as we put X for unknown variables in mathematics, and as he didn't know what he has invented, so that's why he put X-ray. So there was some ray, he understood some electromagnetic radiation, he was physicist, but he didn't know what is this. So that's why he found for the first time, and it was found for the first time in the world. So that's why it was known as X-ray, and till today it is known as X-ray only. And that X-ray is a very powerful electromagnetic radiation, ionizing radiation. Why it is called ionizing? Because it has a capability of destroying or changing the ion structure or atom structure. So it can remove the electron from an atom. So whenever he was inventing or experimenting that, he asked his wife to put his hand, and this was their wedding ring. So that image is very famous. It is the Roentgen's wife's hand, and it was the picture of the bone as well as the wedding ring. So after that, the imaging technique was developed, that is called X-ray planar radiography, where patient or any person stands, and the X-ray is illuminated just like a light, and the backside, just like taking the shadow, whatever we do for our kids with light and say some object, we put some shadow, we show some shadow, and we are playing with kids. Like that also, there will be some illuminator, there will be one screen where we will get the attenuated X-ray, because the X-ray is passing through the body, so it will be absorbed, and automatically there will be the shadow of the bones or skeleton. So whenever if there is any breakage, it will be very nicely visible at the screen. But if it is done for the head, it is very difficult to get, because head has a spherical, say almost spherical cell, which is made up of thick bone, and the X-ray cannot be suitable for getting the inside view of this brain tissue. So in this stage, at this stage, doctor told that this planar radiography is not suitable for brain imaging. So then definitely the tomography came. Tomography means there will be some rotating X-ray beam. Here the X-ray will not rotate, it will be only illuminated for a fraction of a second and done. But here we should get the data from 360 degrees. So it is non-invasive and non-destructive, and it is invented by Hounsfield, Professor Hounsfield and Cormack, and they got Nobel Prize in physics for this development. So where X-ray beam is there rotating, and the X-ray receiver will be there denoted by this circular, the orange color circular gantry. So these are all receivers or X-ray receivers or X-ray receptor or X-ray detector. They will take the data and they will send to the PC, and there will be reconstruction algorithm for the imaging section. So this is the X-ray rotating X-ray beam. This is the patient. This is the bed which can move in this direction, and this is the gantry, and this is the opening through which the patient's body will come. This is a machine. The component is very complex. In the imaging of the abdomen, chest, there is no muscle in the lungs, so that's why it is black, and this is the tissue for the brain. There are several disadvantages. X-ray is radiation, so it is not good for health. It is not possible for long time imaging. And then MRI came. MRI uses magnetic field instead of X-ray, so it is not that much harmful, but it has several precautions. No metal implant should be there, no earring, no necklace, or no metal object, no bangles or metal bangles, anything should be there in the patient's body, and otherwise it will be very much dangerous. And also huge magnetic field will be utilized, so any patient with pacemaker are not allowed. Some other techniques are there for imaging, like nuclear medicine, so PET, SPECT, and gamma camera, which are used also for tomographic imaging. So these are injecting some chemicals and measuring the data, gamma rays, and they are taking the images to get the information about some metabolic condition of the body, and it is useful for detecting the cancers. So cross section of SPECT, single photon computed tomography, emission computed tomography, and then the positron emission tomography, and then this is some schematic of the PET imager, and angiography. There will be some other X-ray imaging. There will be some dye will be injected, and we can get the better images. Fluoroscopy, we will do the same thing, but we will record for the time, longer time, and so that we can capture several frames, so that we can get the some movies of the X-ray images. Mammography, it is used to detect the breast cancer. It is also X-ray kind of imaging, as this type of imaging is used for the breast cancer detection. It is called mammography, but it is similar to the X-ray imaging. Then ultrasound based imaging, I told that if we put ultrasound, it will be reflected by the tissue, and you can get the data, and you can process the data to get the images. It is used for cardiac imaging or any other ultrasound imaging, abdominal ultrasound imaging, and several body parts can be visualized. And microscope is there, that is used in lab. Okay, so these are the comparison: X-ray imaging, ultrasound imaging, MRI, and PET scan. Several images are there, but those instruments are very bulky. Those are not possible to wear. So wearable imaging device is it was difficult. It was found that very difficult for those type of conventional imaging. But whenever the impedance imaging came, we found that it is possible. It is doable. So what is impedance imaging? Before coming to the impedance imaging, I just want to tell you that the interaction between body and electricity is found long back. When the Galvani was doing the experiment with frog's leg with electricity, he found that legs are twitching with the contacts of some conductors, metal conductors. And then after that, the Eindhoven, as I told earlier, Eindhoven developed the ECG machine because he realized that heart has some electricity what can be measured by electronic instrument or electrical instrument. So he put his leg in the salt water, hand in the salt water, and these two are the recording electrodes, and this is the ground electrode as a leg, and he found some voltage is measured. So this is the concept of, or the first device, portable device of, not portable, first laboratory device of ECG machine. So after that, the scientist and researcher realized that there is also one parameter which is called electrical impedance, which can be measured by electricity, and that impedance has several advantages. for measuring. It will be non-invasive, it will be fast, it will be low cost, and from the impedance data there are several health information which are hidden inside that impedance data, which can be revealed and which can be utilized for detecting of several diseases and health conditions. So for measuring the impedance, we need to excite the tissue by alternating current, because if we put the DC current, there will be some electrolysis, so it is not preferred, it is not used generally for human body or biomedical applications. So alternating current means changing the direction as well as the amplitude with respect to time. Whenever some material will be there, there will be the impedance. If we excite that material with the alternating signal, if there are some components like resistor, capacitor, or inductors, depending on that, the impedance will be there. If there is no capacitive or inductive component, resistance will be there, and in the alternating circuit, that resistance itself will be equal to the impedance. There will be series combination or complex combination in real object. If we have any object, either body tissue or any soil or any plastic or any kind of material, each material will have its own electrical property, and that can be revealed by the measurement of impedance. So if we measurement of impedance can be done by injecting some alternating current signal, constant amplitude, and measuring the voltage whatever is shown in the blue color signal, and that impedance can be measured by using the Ohm's law. So we can apply the signal and we can get the other signal. So this is the response. So if we apply current, we will measure the voltage. If we apply voltage, we will measure the current. How the impedance is coming from a body tissue, whether there is capacitive or inductive. There is capacitive component. If we see our body is developed with tissues. Tissues are developed with cells. Cells are always enclosed by the cell membrane. Cell membrane structure is developed with the protein, lipid, protein bilayer. So there will be protein layer, there will be other protein layer, and inside that the lipid layer will be sandwiched. So lipid is non-conducting material and proteins are conducting material. So there will be two conducting materials and one non-conducting material. So definitely capacitance will be generated, capacitance will be found. So due to that cell capacitance, there will be capacitive reactance, and there will be the extracellular fluid, intercellular fluid, and cell membrane. So there will be an equivalent circuit if we inject some current to an isolated cell. This is the modeling, cell modeling. So definitely there will be two parts. One part will be coming through the cell, another part will be coming through the extracellular fluid. So we can get this type of equivalent circuit. There are several other theories also, the equivalent circuit of an isolated cell. So whenever we will inject some current, if low frequency, then the cell membrane reactance will be much more, and it cannot allow the current to flow through it. So definitely current will love to conduct through the low impedance path. So through the extracellular fluid, current will pass. Whenever there will be some high frequency, there will be the current passing through the extracellular fluid as well as through the cell membranes. So utilizing the cell impedance measurement or tissue impedance measurement, there are several techniques: bioelectrical impedance analysis, impedance plethysmography, impedance cardiography, and impedance spectroscopy. Impedance composition, the body composition can be measured by bioelectrical impedance analysis using the 4 electrodes, 2 electrodes on hand and 2 electrodes on body, and we can measure the impedance at 2 different frequencies or much more frequencies, so that we can calculate the body parameter like body water, body fat, and body mass. All these parameters can be measured by utilizing some standard formula which are there. Now measurement of the fluid volume is called plethysmography. Utilizing 4 hands, we can measure the flow of blood, and by this instrument we can see the variation of blood volume inside the body. So same technique is plethysmography is utilized for the transthoracic region, and where we can put the electrodes on the neck, on the chest, near the chest, and we can get the change in the impedance, because blood is pumping by the being pumped by the heart. So automatically there is a varying amount of blood. Definitely blood is varying in amount, definitely the conductivity or resistivity will be varying, and impedance can be measured, which will be a function of time. So comparing with the ECG, we can get some formula which is invented by the Schremek. This is called Schremek formula. Utilizing the formula, we can calculate the cardiac output, which is a very good parameter and important parameter for studying the hemodynamics, and other hemodynamic parameters also can be measured. Measuring the impedance at different frequencies, like doing the spectroscopy, we can get more number of information about the tissue or the human body under test, because we get the frequency response, because impedance changes with the composition, with the anatomy, as well as with the frequency. Now I will come to the imaging of impedance. Till now I explained about the measurement of impedance. Now how the impedance tomography will work? Impedance tomography will be the imaging technique just like the CT, where we will use electrical current instead of X-ray. So the signal which will be generated by this current source will be injected through electrodes, and voltage will be measured either by voltmeter or anything else, and then we will change the measurement position or injection position, and we can get the tomographic image. So this is called electric impedance tomography, and the physics can be understood by this animation, where we are seeing that current is conducted and represented by the red arrows and there will be current paths depending on the circular domain and the conductivity profile. There will be some equipotential lines also shown by these blue dotted lines, and current flux are denoted by the red dotted lines. And now whenever current will be injected, there will be voltage generated throughout the domain, but we will not measure inside, we will measure outside. We will measure all the voltages at the outside electrodes, and that data will be sent to the PC. So automatically we will get some images if we have some image reconstruction algorithm, that is called EIT, image reconstruction algorithm. How it is giving the images, how we are getting the information from the boundary measurement, because if we have some continuous, if we have some homogeneous domain, then the current paths for this type of current injection will be shown by this animation. Now if we have some object, then current paths will be distorted. If this object has higher resistivity, the current will not tend to go through this, it will try to avoid, and automatically current flux will be distorted, and due to that current flux profile, there will be the change in the voltage profile. So automatically we will have the information about this at the boundary measurement. Comparison: X-ray computed tomography measures the X-ray attenuation coefficient utilizing X-ray, and in impedance tomography it measures the electrical impedance or conductivity using the electrical current. It is invented by Professor John G. Webster and R.P. Henderson in 1978. After that, Dr. Barber and Brown, they utilized that technique for biomedical applications, and after that several advantages are found, and it is applied in many engineering and technological fields, and also in the applied sciences. So it is non-invasive, radiation-free, low-cost, portable, bedside measurement possible, suitable for military monitoring, and so on. Application: it may be it can be utilized for medical imaging. In chemical engineering, it can be utilized. In microbiology, cell culture can be visualized. In defense field, mine detection is possible. In civil, the detection of crack and void can be possible if we put the electrodes on the concrete beams. Even in the geotechnology, if we put the electrodes on the ground, you can visualize the water and the mineral under the ground. There are several techniques for injection, opposite or neighboring. I will just go quickly due to the lack of time. So this is a measurement scheme. We will measure the voltage at the boundary, and here we will show the scan by this animation. So we will measure all the voltages at the boundary. So we will get a set of data, and after that we will change the current injection, and then again we will measure the set of data, and we will keep changing the current electrode position, and we will get several matrix, and there will be several data matrix, and that matrix will be taken to the algorithm, and we will get the imaging devices, imaging of the object under test. This is a simulation results. We developed some simulation, we did some simulation in the computer, we generated the data in the computer simulation, and then we took the data in the image extraction algorithm called ADAS, and then we can get the images. So these are real images. Real means it is simulated images, and then that data is collected and reconstructed here. So it is matching with the structures. Real system is developed with some instrument. I told constant current source is required, signal conditioner block is required, data acquisition system, and multiplexer block. These are the all instrumentation block which are required. How it is working? So signal will be generated by a voltage control oscillator, then current source, then it will go to the marks, and then it will go to the object. Voltage will be developed, and the voltage will be passing to the instruments amplifier, then filter blocks, and then voltage measurement, and then it will go to the CPU. Instrumentation, it can be developed either in breadboard or PCB. as we know all how to do the PCB, so I am skipping that. It may look like a PCB board, just like a motherboard of computer, and then there will be some electronics which will be suitable for EIT experiments. So these are the all IC related information which can be utilized for generating the function generator, generating the signals, voltage signal, then current converter, then multiple amplitude current converters can be also done. This is the full signal conditioner blocks, and this is the full system which can be found as suitable for EIT imaging. And this is the PCB design, whatever all the circuits whatever I have shown, that is developed in the PCB. And this is the multiplexer switchboards connections. Okay, so this is the initial stage of the instrument, EIT system. This is the responses, then PCB system, and this is the marks. These are personal multiplexers. I am skipping that because we know all how the multiplexer works. So this is the, here you can see the picture of the instruments, how the electrodes are moving and how the data are measured. So this is the neighboring method of current injection and voltage measurement, and this is the another stage where we use the national instrument cards instead of manual switching. Battery based system. At the final stage of my PhD I developed that, and this is the phantom with the resistive material, and you can see the circular red spot at the position of this object, and the blue background is the saline background. It will be look like this image reconstruction, and this is the phantoms. Phantoms is the models by which the system can be tested, because we cannot apply the system directly on the human body, and it can be utilized or developed with a James clip even, but after some experimentation it will be corroded due to the saline and water. We use the stainless steel electrode phantoms also to avoid the corrosion, and this is the some phantoms with real tissue, chicken fat, and chicken tissue and bone, like that we have tested. Even the vegetable based saline phantom are also developed, and these are on the nylon cylinder or wood cylinders. This is the graphical user interface for the system, and applications: chest imaging and neonatal imaging, that is for babies, breast imaging, and the brain imaging, and cell culture imaging. So these are the commercial devices right now available from UK, from Russia, and from the Germany. But at the stage of the wearable devices, EIT wearable devices are also possible. There are some devices developed by researchers where we can wear the EIT system on our hand, and we can get the images in the computer through either Bluetooth or through other device, other wireless technology. If we close the hand, our image will be changed due to that, because our muscle position is changing, and that is detected here. And wearable devices technology can be utilized for the breast imaging through EIT also. Chest imaging is also possible through EIT, and which can be made wearable utilizing the sophisticated belt developed by KAIST in one university in Korea, South Korea. And that is the schematic of the wireless communication, how the chest imaging can be made, and even the 3D imaging can be utilized, can be developed utilizing the several layers of electrodes. So conclusions: physiological monitoring is required for studying the human health for disease detection. Wireless physiological monitoring enables us to remove the connecting wires with flexible measurement process. Wearable devices have many advantages in physiological monitoring. EIT is a CT scanning technique which has the several advantages. With the help of IoT technology, wearable technology has helped a lot in patient monitoring. Wearable EIT system has a lot of potential in medical diagnosis. A number of research opportunities are there to explore the nature and behavior of the wearable instrument based on the medical, used in the medical science. I thank my research supervisors with whom I worked and my collaborators. I thank Dr. Nisha Sudha for inviting me for this FDP. I thank all the faculty members and organizing committee of the FDP. I thank Karuna Institute of Technology of Science, Coimbatore, and Department of Electronic and Communication Engineering, KITS, Coimbatore. And I thank, above all, I thank all the participants who has spent their valuable time to listen to my talk. Thank you very much. I will be happy if there is any doubts and questions, and even it is not possible to answer within the short time, I will be very happy to receive all the questions through my email and contact numbers, whatever shared in the screen. Thank you.
Thank you, sir, for your valuable time and sharing your knowledge and ideas with us with your detailed presentation on the various challenges and possibilities in wireless physiological monitoring with wearable medical instruments. Now the session is open to the participants. The participants can unmute their mic and raise their queries.
Good afternoon, sir.
Good afternoon.
Sir, my name is Dipali.
Very nice to meet you.
Sir, the session is the same here. So the session is very informative. I congratulate you for the same. And sir, I would like to ask one question related to the, not only related to the wearable device, but whatever data we are collecting from the wearable device. And in one of the diagram, you have shown that EHR is there. So, sir, my question is related to EHR. That could you please put some light that how much percentage of implementation or how successful is EHR in India right now? Do you have any idea? Sorry, sir.
At which slide you can please tell?
Sir, where the data is collected from the monitoring device. And then the clinician is there, EHR is there, and database is there.
Okay, percentage actually I also don't know, but I need to check and I can get back to you.
Okay.
What percentage is
yes.
there? Okay.
Yes, sir. My question is like whatever data we are getting from the wearable devices. So, is it really helping the e-health services in getting the quality care in India?
Whatever we are getting, that is actually quality care means you cannot compare with the non-wearable devices, because there will be several challenges if we have the wearable devices. But why we are going for wearable devices? Because there are some very, very strong advantages, because in many times, either due to the busy schedule or due to the communication problem, it is very difficult to go to the clinic sometimes for particular patients. And during that time, if we have the wearable devices, either with monitor, analyzer installed within it, or that there will be some remote monitoring system will be there. In both the cases, at least data will be monitored and it will be under supervision of the doctors. So in that case, the wearable devices has a very big potential for giving the medical facility to the person who are not directly in contact with the hospital or clinicians. So in this way, we can tell that it is really helpful. But if we tell that quality, so quality means if it is you are talking about the quality healthcare, then it is okay, because doctors will tell that whether data is sufficient to diagnose or not, whether the data is visible or not, whether there is any noise or not. That is technical problem that can be solved. But definitely it will be very, very helpful for the persons in certain circumstances.
Okay, fine, sir. And sir, if you permit, I have one more question.
Yeah, please.
Yes, sir. Sir, in yesterday session, we have learned and discussed the harmful radiations effect on our body. Mm-hmm. And sir, when we are saying that we are using mobile phone or wired or this radiated wearable devices to understand or to collect the data. So do you think that it is really advisable to use these, matlab, not all, but some of the devices which can, do harm to our body?
Yeah,
So
definitely,
what do you
definitely.
think that?
Yes, yes.
Yes.
I will tell that the wearable devices is not prescribed or say good for any other patient who have some certain physical conditions like say pacemaker wearer who has the pacemaker inside it, or definitely we need to know about the radiation. Okay, so whenever we are going for wearable device and wireless, definitely there will be electromagnetic radiation. But before taking the technology, we must know about the safety of the say radiation safety band, whether the company has mentioned about the radiation level or safety level. That should be also maintained and monitored. Otherwise, it is not prescribed.
Okay, sir. And sir, one more question, sir, because you have said that you have, done the research. So I would like to know that from your experience that do the companies, the vendors which are, manufacturing it or designing it, are they really looking in the safety precautions measures or not? Or are they
Yeah,
really only?
that is very very critical question and controversial answer may be there. So I am not the right person to tell whether companies are doing or not. We can discuss not in the official form means platform, and we cannot claim, and it is very difficult to prove if some company is not maintaining that. So it will not be good to mention, or it will even I am not be able to mention who is doing or who is not doing. But for that we should believe on our government of the nations, and government should have the duty to. Government will have some sectors, medical sectors, who are giving the certificates. So those departments should work to monitor, and so that all the companies are bound to maintain the radiation related safety and the medical safety. So for that only the government will be the right person to give the answer and take care of it. So I will not be because we can understand several things, but we cannot get the proper reason by which, suppose we have taken some wearable instrument and we are not feeling well, or somebody has some problem. So there may be several issues also, either his or her physiological problem or instrument will have some problem. So those things should have require a lot of studies, and the proper authority should actually check and they should act. We cannot do that. As a researcher, we can only judge that whether the radiation is there or not, but we cannot tell actually that these companies are doing or not. Definitely companies should do. As a say ethics, they should not violate the rules, whatever is fixed by the government of any nation regarding the health safety. So they are bound to do that, but if they are not doing, that is the matter of say negligence, and also the government should take care of that.
Thank you so much, sir. Thank you.
Yeah.
Sir, can we have your contact details?
Yeah. At the last slide or first slide, I am just going to the last slide. So you can contact me anytime, and if any question you have in future, just give me an email. And I may not be able to answer all the questions because I am also a learner. So definitely I will help you to get the answer. Either I will share some documents, or even I will also learn with you and I will share with you. So that is always welcome.
Thank you.
Yeah, you can see the last slide.
Yes, sir, it's visible. Yes.
Yeah.
Sir, I have one question. So
yes,
normally we have phantom model in the simulation setup.
Yes.
In your presentation, you shared something about the liquid phantom model.
Yes.
Yeah, sir, can you share something how this liquid phantom model developed?
Yeah, actually I used the saline solution which are available in the medical shop. So that is 0.9% NaCl solution.
Okay.
So I use that and I measure the conductivity and impedance of that saline solution using the impedance analyzer or any other impedance measuring device like LCR meter. After that, I pour that solution in the tank, and tank is housed with some electrodes. I used 16 electrodes during my PhD and I used 32 electrodes during my postdoc. So any number of electrodes can be utilized, but depending on the number of electrodes, you have to develop your computational model. And
okay,
so computational model must have the same geometry, exact same geometry, whatever is there in your practical phantom. That should be the most of the importance in phantom design.
Okay, sir. Okay, sir. Thank you. Thank you, sir.
Thank you very much.